Okay. Hello, everyone. My name is Jiao Pengju from China Mobile. Xu Lei and Bao Fangyan are my colleagues. They couldn't get to the scenes for the special reasons, so I take place with them and talk about this topic with you. China Mobile's private cloud project at Hohehot data center has built 1,800 virtualization nodes and 3,000 baremetal nodes for single pod. We use SDN supported by China vendor, serversan and DFS supported by Huawei, and fcsan supported by Hightech, only for baremetal servers. Now this resource cluster has hosted company internal business. Here is the architecture of OpenStack. We use two regions to separate virtualization nodes and baremetal nodes. Considering the pressure of cluster, Keystone distributed on 15 nodes use independent database in the virtual machine region instead of general modules, Nova, Glance, and Sender. Other components like Celemeter and Nokia are also installed for virtual machines monitoring. Besides, Guardian is designed by China Mobile, working for thousands of virtual machines HA. For baremetal region, Ionic Inspector can make BM management easily. Each region has 3 Neutron nodes and share one database. They can keep network data coherency. We adopt a network schema by China vendor, use DVS, is DPTK and OVS, and SDN hardware switch for performance and flexibility. Data center levels double layer Hotgirls firewall is combined with our private cloud. In the firewall, use the Neutron module for VPC interconnection, and out firmware works for access policy of internet, which is controlled by our private cloud web portal. For storage, 3 backends are used for our private cloud. serversan is Huawei Fusion Storage, attaches a capacity type block device to virtual machines and baremetal by SCSI protocol. fcsan, Hightech HDS, provides a performance type block device just for baremetal. Manila manages DFS, is Huawei Ocean Store 9000, to provide a shared file system for virtual machine and baremetal servers. DFS is also used for glance images. Both virtual machine region and baremetal region, NOAA schedule as a single process program, will be a bottleneck in large-scale environment. For one hand, lots of NOAA compute will send RPC request to NOAA schedule every period, leading to performance degradation. For another hand, when many APIs for creating VM or VMs send concurrently, NOAA schedule will hang at get all host state method. More APIs send, more time need to wait. If this waiting time exceeds the RPC timeout, all creating operations will fall finally. Also, Keystone will burden pressure when virtual machines increasing. So how to optimize configuration parameters will be a key to maintain this large environment stable. We found when concurrent creations occur, NOAA schedule will be received RPC call to evoke select destinations methods and run in get all host state method simultaneously. In table 1, we record the RPC numbers received by one NOAA schedule and the processing time for selected destinations. We can see when RPC numbers increase, average time of processing also increases linearly. This indicates that all simultaneously requests hang in reading database. To improve the performance of concurrent creation, we use caching schedule instead of filter schedule. Caching schedule is a subclass of filter schedule. Also use the all filters and all waits, but caching schedule rewrites get all host state method as a period task. Host information will be gathered every 60 seconds. So simultaneously, requests don't need to read the database, and the processing time of schedule will be greatly shorted. In table 2, we can see 100 times of simultaneous requests will be resolved in 2 seconds. By the way, now China Mobiles wanted to use pack instead of kilo as a base version gradually. I think use the filter schedule and the placement can't resolve this problem. Also use the faulting in database and allocation quantities, especially in large scale and small flavor. We noticed that NOAA community in Rocky development has made a trade-off in performance and accuracy. NOAA community configuration parameter is another factor for NOAA optimization. 1,800 commuter nodes will cast the sync instance info RPC to NOAA schedule. If cluster just has one NOAA schedule, all requests processing time will expand. In table 3, we can see one NOAA schedule and 5 NOAA schedule in large-scale environment processing time for schedule request. Besides, we adjust the period task time for heartbeat pressure. Set 60 seconds to report level, report interval, and set 3 times than it to service downtime. Recently, I found when virtual machines created in OpenStack in creating, Keystone and Neutron is called 500 times every second. Keystone read endpoint information, also bring stress to database and occupy lots of management network bandwidth. Finally, discovered that a period task, here instance info cache in NOAA community will send API to Neutron for port updating, and the default value is 60 seconds. Change it to 600 can solve this problem. Like NOAA schedule, send volume is also a single process program. It's for backend. We use Huawei serversan for virtual machines system disk. Images for business is 10 gigabytes and placed in DFS. How we can create volumes with images quickly and stably? At first, I optimize nothing for sender, and notice that sender will pull images from glance to inventory via sender conversation, then push to serversan and delete it. This cost a lot of time, and then I used image cache for virtual machines image creating. Image cache is designed very simple. It uses a parameter in send volumes driver configuration file and set it to true. Now, when we create a volume with new image, we'll use a sender internal tenant user to save or record this volume ID, size, and timestamp. Pull image and push to empty volume as an image cache. Then it will use create from source volume to copy a new volume from image cache. If we create another volume with this image, it will search this image cache and update timestamp. Then to copy a new volume from image cache. The code process can refer to the above picture. Okay, as everyone knows, storage backend copy capacity has a limit. Huawei serversan concurrent copy limit is 20, and how to coordinate sender process synchronization with limit. At first, we add a process log in driver, method create volume from volume. So when a sender volume process copying a volume, other requests should wait to acquire the log. But how to match the limit accurately? I use Docker for sender volume and set same host in the sender configuration file. This solves the problem and achieves the best performance. Channel vendor DVS need use 4 gigabits huge page and 6 cores. So we set all virtual machines with NUMA parameters. We left 4 cores and 32 gigabits RAM for system and others used for virtual machines. The parameters vCPU pin set in NUA configuration can reserve cores for NUA compute nodes. We also develop parameter reserved huge memory for NUMA nodes sets for resource statics. If customer need a large flavor, which extending the NUMA limit, like 12 CPU, 320 gigabits RAM, we also can change the flavor key to create no NUMA VMs. Core and DMZ zone is common in data center, standard for different network access. We use AZ concept in OpenStack successfully to integrate with trust zone and demilitarized zone. For NOA, we created 2 aggregates, core and DMZ. We set 375 commuter nodes to DMZ and others to core. For Sender, we set a host with core and DMZ to modify pressure for different zones and easy to debug. For Ionic, we develop extra AZ in VM information in order to be managed by different zones. AZ in Neutron is most important for our cluster. We created 2 VPC router, DMZ and core router. Each router mapped to an inner virtual firewall. Inner firewall is accessed with SDN controller, set DMZ and core interact policy. In the picture, core zones access to carrying network should run from inner firewall D. This is a trade-off. For DMZ zones, access CMNet directly from outer firewall D. We found that Ionic pod just has controller nodes in cluster. I think it can be easily deployed by Kubernetes. In the picture, all container images are built and uploaded to Docker registry. Controller nodes are tagged core or bus. Core node just has a management network, and the bus node has both management network and a business network. Our OpenStack service can be easily run as a container and set to different nodes. Use demo set. That's all. Thank you.